Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, customer segmentation using machine learning. What is customer segmentation? Customer segmentation means grouping customers according to various characteristics like age, annual income, spending score, etc. It's good way for organizations to understand their customers. Knowing the difference between customer groups, it's easier to make strategic decisions regarding product growth and marketing. The opportunities to customer segmentation are endless. It is totally depend on how much customer data you have. So for this project, we are going to use mall customers dataset available on Kaggle. You can download this dataset from Kaggle or from my GitHub account. Link is given in the description of this video. So what is this dataset about? As you can see, first 5 rows of our dataset. This dataset is made by mall, means by strategic team of the mall, with following information like customer ID, gender, age, annual income, and spending score. This spending score takes value between 1 and 100. This spending score is made by mall to know how each customer spends. For example, customer with customer ID 2 spends very high in the mall. Customer with customer ID 3 spends very less in the mall. And as you know, this spending score takes value between 1 to 100. And here in this dataset, each row corresponds to the customer of the mall. So by this data, strategic team want to understand their customers, means they want to identify some patterns within their customers. As you can see, in our dataset, we have only independent variables. There is no any dependent variable in our data set, means we don't know what to predict. So this is unsupervised machine learning problem. Our main goal is to identify patterns within customers. We don't want to predict anything. To do this, we are going to use k-means clustering algorithm. So what we are going to do? At the end, what we will get? Please remember, we are going to create dependent variable which contains finite number of values like 1, 2, 3, 4, 5, etc. Means cluster numbers. This customer belongs to which cluster? Please remember, at the end, our clustering algorithm gives us finite number of values like 1, 2, 3, 4, 5, etc. Means cluster numbers. Means we are going to create dependent variable at the end. This is the exact idea behind clustering. We are going to create dependent variable. Means customer with customer ID 1 belongs to cluster 2. Customer with customer ID 2 belongs to cluster 3. Customer with customer ID 3 belongs to cluster 2. Customer with customer ID 4 belongs to cluster 3. Customer with customer ID 5 belongs to cluster 2. So as per these 5 rows, our customers are divided into 2 clusters that you can see over here. 2, 3, 2, 3, 2. Means customers with customer ID 1, 3 and 5 belong to one cluster 2 that you can see over here. Customer with customer ID 2 and 4 belong to another cluster 3 that you can see over here. So as I said, at the end, our clustering algorithm gives us finite number of values, means number of clusters. This is the exact idea behind clustering that you can see over here. We are going to create dependent variable. So let's get started. So for this project, here I have mentioned some questions. So now let's solve them one by one. Before that, we have to load our dataset. So for that, let me import pandas as PD. Let me execute this cell. As you can see here, now our pandas library is successfully imported. So now let's load our dataset. So for that, let me write pd.read_csv because our dataset is available in .csv file format with name mall_customers.csv. Let me assign it to one variable data is equal to this statement. Let me execute this cell. Now our dataset is successfully loaded as pandas data frame. So now our question number 1. In this question, we have to display top 5 rows of our dataset. So for that, let me write data which is pointing to our data frame here. And we have to use head method of pandas data frame. Let me execute this cell. As you can see here, by default, head method is displaying top 5 rows of our dataset that you can see over here. So this way we can display top 5 rows of the dataset using head method of pandas data frame. So now our next question. In this question, we have to check last 5 rows of the data set. So for that, let me write data and we have to use tail method of pandas data frame. Let me execute this cell. As you can see here, by default, this tail method is displaying last 5 rows of our data set. By that, we can able to know total how many rows are available in our data set. That you can see over here. So this way we can check last 5 rows of the data set using tail method of pandas data frame. Now our next question. In this question, we have to find shape of our data set, means number of rows and number of columns available in our data set. So for that, we have to use shape attribute of pandas data frame. Please remember, shape is an attribute of pandas data frame. It is not a method. Let me execute this cell. So output is Python tuple. This is at index 0 and this is at index 1. Let me display it in proper format with this print function. Let me write number of rows data.shape index 0 and let me write number of columns data.shape index 1. Let me execute this cell. As you can see here, in our data set total we are having this many rows. In our data set total we are having this many columns. So this way we can find shape of our data set, means number of rows and number of columns using shape attribute of pandas data frame. So now our next question. In this question, we have to get information about our data set like total number of rows, total number of columns, data types of each column and memory requirement. That we can do with just one method, info method of pandas data frame. Let me execute this cell. As you can see here, total we are having this many rows in our data set with this indexes. As you can see, column names. As you can see in our data set, total we are having this many nominal values in this particular column. This many nominal values in this particular column. Likewise, and data type for each column that you can see over here. As you can see here, D types column means in our data set 4 columns with integer data type, 1 column with object data type and memory usage for our data set. So this way we can get information about our data set like total number of rows, total number of columns, data types of each column and memory requirement using info method of pandas data frame that you can see over here. So now our next question. In this question we have to check null values in the data set. So for that let me write data and we have to use isNull method of pandas data frame. Let me execute this cell. As you can see here, output is pandas data frame with boolean values. Now let's find sum of true values using this sum function. As you can see, output is 0, 0 and 0, means we do not have any null value in our data set. So this way we can check null values in the data set. So now our next question. So in this question we have to get overall statistics about our data set. So for that we have to use describe method of pandas data frame. Let me execute this cell. By default this describe method is displaying statistics only for numerical columns that you can see over here. Let me take one column age. So number of rows in this particular column age, average value in this particular column age, standard deviation of this particular column, minimum value in this particular column, and these are percentile values like 25%, 50% and 75%. Means in this column 25% values are below this. In this particular column 50% values are below this. In this particular column 75% values are below this. Same for other columns, and maximum value in this particular column age. So this way we can get overall statistics about our data set using describe method of pandas data frame. So now our next question. In this question we are going to use k-means clustering algorithm. So let me first display column names, and we are going to use only 2 columns for teaching learning purpose, and also we can visualize clusters easily. So let me write x is equal to data and let me copy this column name and let me paste it over here, comma. Let me copy this column name, spending score, and let me paste it over here. Let me execute this cell. Let me check. As you can see over here, for teaching learning purpose, we are going to use these 2 columns, annual income and spending score. So we can visualize clusters easily. Now let's use k-means clustering algorithm. So for that we have to import from sklearn.cluster, we have to import k-means. Let me execute this cell. As you can see, now k-means clustering algorithm module is successfully imported. So now let's create instance of this k-means clustering algorithm. Let me write k-means. You can use any. Now let's train our k-means clustering algorithm. So for that we have to use fit method, and here we have to pass our data which is available in this data frame X. Let me execute this cell. As you can see here, now our k-means clustering algorithm is successfully trained on our data. So now let's identify clusters. So for that, let me copy these statements and let me paste it over here. And to identify number of clusters, we have to use fit_predict method. So please remember, this fit method only train our algorithm, but this fit_predict method not only train but also create dependent variable, means clusters. Let me execute this cell. As you can see here, so as I said, this fit method only train our algorithm. So this is not only fit but fit plus predict, means this method fit_predict not only train but also create dependent variable, means clusters, that you can see over here. So here minimum value is 0 and maximum value is 7. Why? Let me check. So let me press Shift tab over here to check docstring of this k-means clustering algorithm module. As you can see, by default number of clusters are 8 and initialization method is k-means ++. So these are some default values that you can see over here for our k-means clustering algorithm. And as I said, by default number of clusters are 8. So that's why here 8 values 0 to 7. So now our customers are divided into 8 clusters, means into 8 groups by our k-means clustering algorithm. So as I said, at the end our clustering algorithm gives us finite number of values, means cluster numbers. This is the exact idea behind clustering algorithms that you can see over here. So our k-means clustering algorithm gives us 8 clusters by default. As you know, by default clusters are 8, but we can change it to any value using this n_clusters parameter of this k-means clustering algorithm. So we can use n_clusters and we can set it to any value. The question is, do we have to use this number of clusters by try and error? No. To find the optimal number of clusters, we can use elbow method. So in our next question, we are going to use elbow method to find optimal number of clusters. So now let's use elbow method to find optimal number of clusters. To find optimal number of clusters with this elbow method, we are going to run this k-means clustering algorithm with several number of clusters. First time with 1 cluster, second time with 2 clusters, likewise up to 10 clusters. So each time when we run this k-means clustering algorithm with several number of clusters, it computes WCSS, within cluster sum of squares metric, and we are going to store this WCSS within cluster sum of squares metric into Python list, and then we will visualize number of clusters with WCSS within cluster sum of square metric to find optimal number of clusters. Let me show you this. So for that we have to use for loop to run k-means clustering algorithm several times. So for I in range 1 to 11, and let me create instance of k-means clustering algorithm, and here let me pass n_clusters parameter. So in place of some static value like 5, 7, and as you know by default value is 8, but here we have to pass I. So it will run k-means clustering algorithm first time with 1 cluster, second time with 2 clusters, and at the end it will run k-means with 10 different number of clusters. And let me assign it to one variable, k_means is equal to this statement. Now let's train this k-means clustering algorithm. So as I said, we are going to run this k-means clustering algorithm with different number of clusters. Each time it will compute WCSS within cluster sum of squares metric, and that we are going to store into Python list with name WCSS. You can use any. So now let's append this computed WCSS into this Python list. So these calculated WCSS values are available into one attribute of k-means clustering algorithm, inertia. So for that we have to write k-means dot inertia. So this inertia attribute of this k-means clustering algorithm contains calculated within cluster sum of squares metric, and that we have stored into this Python list. Let me execute this cell. Let me check. As you can see here, calculated value of within cluster sum of squares by different values of clusters that you can see over here. So now let's visualize it. So for that I am going to use matplotlib library. So for that we have to import matplotlib.pyplot as plt. Let me execute this cell. As you can see here, now our matplotlib library is successfully imported. So let me write plt.plot. On x-axis, let me display number of clusters 1 to 10, and on y-axis WCSS within cluster sum of squares metric that we have computed over here. Let me execute this cell. As you can see over here, now let's decorate this plot. So for that let me write plt.title elbow method, and let me write plt.x label number of clusters and plt.y label WCSS, and let me write plt.show. Let me execute this cell. As you can see over here, number of clusters and within cluster sum of squares metric that you can see over here. So by this elbow method we can say that here optimal number of clusters are 5. Why 5? Because as you can see here, graphs decreasing strongly up to this point 5, but after number of clusters 5, graph decreasing slowly. So we can consider this as a elbow point. Here we can say optimal number of clusters are 5. So this way we can use elbow method to find optimal number of clusters that you can see over here. Now our next question. Here in this question we are going to train our k-means clustering algorithm with optimal number of clusters 5 that we found over here. So first of all, let me copy this statement and let me paste it over here. Let me execute this cell. Let me check. As you can see over here. Now let me create instance of k-means clustering algorithm with n underscore clusters equal to 5, and let me set random underscore state to 42 so we can get same samples in each run, and let me assign it to one variable k underscore means. You can use any. Now let me write k underscore means dot fit underscore predict, and let me pass our data available inside x. As you know, this fit underscore predict method not only trains but also returns dependent variable means clusters. Let me assign this to one variable y underscore means. You can use any. Let me execute this cell. Let me check. As you can see over here, now our customers are divided means segmented into 5 clusters 0 to 4. So these 5 clusters contain different group of customers means similar customers are in the same group. For example, customer with customer ID 1 belongs to cluster 2. Customer with customer ID 2 belongs to cluster 3. Customer with customer ID 3 belongs to cluster 2. Likewise, let's visualize these clusters on 2D plot. So for that I am going to use scatter plot of matplotlib. We have already imported matplotlib over here. So plt.scatter. So let me write our data frame x, and to select rows and column I am going to use iloc method. In this bracket notation let me write comma. Here we can pass rows that we want to select, and here we can pass column that we want to select. So here first column. So for that here let me write 0. For annual income, here we have to pass all the rows for the customers belong to cluster 0. So for that we have to write y underscore means, this one. So we are going to select these customers which belong to cluster 0. So here equal 0 comma. So this is for x axis. On y axis let me write iloc and column number 1 spending score, and all the rows for the customers belong to cluster 0. Y means is equal to 0, and let me set size of points to 100 so we can visualize it properly, and let me set color to red, and let me set label to cluster 1. Please remember, actually this is cluster 0 but we are considering it as a cluster 1. Let me copy this statement and let me paste it over here. For 5 clusters, so here we have to change y underscore means to 1, 2, 3 and 4. Same over here 1, 2, 3 and 4. Let me write plt.legend. So it can show these labels. Let me change it to 2, 3, 4 and 5. Let me execute this cell. As you can see over here, our 5 clusters. Let me change color of these clusters. Let me set color to yellow. You can use any. Here green, here blue, here black. Let me execute this cell. As you can see over here, now our customers are segmented into 5 groups that you can see over here. Also we can display cluster centroid using kmeans attribute. Let me show you this. So plt.scatter k_means dot cluster underscore clusters, all the rows and column 0. Let me copy this statement and let me paste it over here. All the rows, column 1, spending score. And let me set size 200 and color to magenta. Let me execute this cell. As you can see over here, now we can see cluster centroid that you can see over here. Now let's decorate this plot. So let me write plt.title customer segmentation, plt.x label, this one on x-axis annual income, plt.y label spending score, and let me write plt.show. Let me execute this cell. As you can see, now our customers are divided into different groups. As you can see here, cluster 1, this one, customers with medium annual income and medium annual spend. Cluster 2, this one, customers with high annual income but low annual spend. As you can see, cluster 3, this one, customers with low annual income and low annual spend. Cluster 4, this one, customers with low annual income but high annual spend. Cluster 5, this one, customers with high annual income and high annual spend, that you can see over here. According to these customer groups, strategic team will decide for which product we have to target which customers. So it's a good way for organizations to understand their customers. Knowing the difference between customer groups, it's easier to make strategic decisions regarding product growth and marketing, that you can see over here. This is the exact idea behind customer segmentation. So now let's perform prediction using k-means clustering algorithm. So let me write k_means instance that we have created over here, this one, dot predict. And here in 2D list, we have to pass annual income and spending score. I am taking 15 as annual income and 39 as spending score. Let me execute this cell. As you can see over here, output is 2. Please remember here, cluster index start with 0. So actually it is cluster number 3, this one. So with these values, customer belongs to cluster 3, customers with low annual income and low annual spend. So that's why it's a good way for organizations to understand their customers, that you can see over here. So this way we can perform prediction using our model. In this question, we are going to save our model. So again and again, training is not required, and we can perform prediction using this saved model. So for that, I am going to use joblib library. So let me write joblib. Let me execute this cell. As you can see here, now our joblib library is successfully imported. So now let me write joblib.dump to save our model. And here we have to pass model instance k_means. And here you can give any name. Let me write customer_segmentation. You can write any. Let me execute this cell. As you can see here, now our model is successfully saved with this name. So in future, we can perform prediction using this saved model. Let me show you this. So for that, we have to write joblib.load to load our saved model. And as you know, we have saved our model with this name. Let me copy and let me paste it over here. And let me assign it to one variable, model is equal to this statement. Let me execute this cell. As you can see over here, now our model is successfully loaded. Now we can perform prediction using this saved model. So let me write model.predict and let me pass 15 as annual income and 39 as spending score. Let me execute this cell. As you can see over here, same output 2. As I said, clusters index start with 0. So this is actually cluster number 3. This one, customers with low annual income and low annual spend, that you can see over here. So this way we can perform prediction using our saved model. As you can see, I have created GUI for this project, customer segmentation using machine learning, that you can see over here, exactly same way as we have created for other projects. I'm sure you must be knowing this. Let me execute this cell and let me execute this cell as well, as you can see over here. So here we can pass annual income. Let me pass 15, and here spending score. Let me pass 39. Let me press this predict button. As you can see over here, for this annual income and this spending score, we can consider this customer with low annual income and low annual spend, that you can see over here. So as you can see over here, now it's become easier for strategic team to make strategic decisions regarding product growth and marketing using this machine learning algorithm. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.